When we apply any log in any base to a product, let's say x times y, this changes into a sum of the two logs. Don't say that we are distributing. We're not distributing anything. But this is the same with this. I meant to write y. So if we apply log to a product, then we can change it into the sum of the log of x plus log of y. As an example, if I have log base 3 of 2 times 5, I could write it as log base 3 of 2 and plus log base 3 of 5. Also, this formula or property or rule has to be understood from left to right and from right to left. If I'm given this and they have the same base, I should be able to go back and say, oh, I know this is log base 3 of 2 times 5 or log base 3 of 10. So from left to right as well as from right to left. This is the first rule. Rule number 2 is the quotient rule. Identical with this, but it's a ratio. And the difference is that it's going to be a difference, not a sum. This one is in the denominator. It will have a minus in front. This one is in the numerator. It will have a plus in front, which we don't have to write. Log base a of x. Of course, it goes back and forth. If I'm given a difference of two logs and they have to have the same base, if they do, then I can go back and write this. Where the log with a minus in front, its quantity has to go to the denominator. Or we know its quantity is coming from the denominator. As an example, if I have, let's say, log base a of 4 over 5, this is the same with log base a of 4 and minus, because the denominator, minus log base a of 5. And I should be able to go back. If I have log base 4 minus log base 5 and they have the same base, then this is 4 over 5. Log applied to 4 over 5. Not to be mistaken with log base a of 4 over log base a of 5. This is not what we are talking about here. We've seen this one time, which is this. But that has nothing to do with this property. I'm not saying is the ratio of two logs. I'm saying is log applied to a quantity that is a ratio. Last property. Any questions? Last property is the power rule. So we had the product, we had the quotient, and now we have the power rule. Last one, power. Log in any base of x raised to a power, any power. This power goes in front as a factor, meaning it multiplies log. Don't write plus or minus or anything else. So this becomes b times log base a of x. So for example, if I have log base a of x squared, 2 goes in front as a factor, so 2 log base a of x. And these are very important properties. There are other minor properties, not as major as these ones. For example, so other properties. Log in any base of the base. Remember, a raised to which power is a? Well, the answer is 1. The same thing, log of 10. 10 raised to which power is 10? Obviously, it's 1. The same natural log of e. The base is e. E to which power is e? 1. So these two are examples of this. Another example will be log base a of 1. I don't know what that is. I'm asking myself, a raised to which power is 1? Well, it must be 0. Okay, now let's practice. We are going to look at two different things, and the page number, I'm getting to it in a second. Page number. We are going to expand and we are going to condense log expressions. I will be able to find it in a second. Yes, page 501. So please, let's choose from 1 through 40. 501. So here we want to expand. We are going to use all properties, all three properties, and expand a log applied to a complicated expression. Anyone would like to choose? Anyone? Okay, I will. I will start with 27. In 27, I see log base b of x squared y over z squared. And I know we have a property for the ratio. That's how we start. If the expression has a ratio, we start with the ratio. And what do I know? I know that it's log applied to the numerator minus log applied to the denominator. And this was the rule right here. Log applied to the numerator minus log applied to the denominator. So log base b of x squared y, but minus log base b of z squared. Is this enough? No. Because now I see I have a product. And also I have a power. So then, how do I address log of a product? It's log of the first quantity plus log of the second factor. So log base b of x squared plus log base b of the second factor. Minus, I bring 2 in front, 2, log base b of z. This cannot be further simplified. I don't have any other property to apply. I don't have any other property to apply, but I do have a property to apply here, which means just put the 2 in front, and it's completely expanded into simple logs. There are no other properties that we can apply. There's nothing else to do here. So the final will be 2 log base b of x plus log base b of y minus 2 log base b of z. So we completely expanded the expression, the log that was given to us from a complicated expression. We simplified it into very simple logs. This is a very important procedure, and the even more important procedure will be when we are given this, and we will be asked to condense it into this. That's even more important. So would we like to expand more?
Yeah, can we do 39?
39 it is. Yes, 39. Very good. Good pick. 39. Where are you? 39. Yes. Log applied to. The top has 10x squared. It has this, I think it's the cube root. My devices, as you know, are so far away from me. I think I see the cube root. Is it? Over 7 x plus 1 squared. Did I copy the correct problem?
Yes.
Okay, perfect. So now, first of all, I would like to show you a little bit of a shortcut. How many factors I see at the top? 1, 2, 3. How many factors I see in the denominator? 1, 2. 3 of those logs will have plus in front. 2 logs will have minus in front. And I skip a lot of steps if I remember that. So log of 10 plus log of x squared plus log of the cube root of 1 minus x, but minus log 7, but minus log x plus 1 squared. Let's stop for a moment and discuss this. Do we understand what just happened? Instead of going step by step and writing the quotient first and then splitting the product and then distributing the negative sign, etc., etc. Do we understand this step? If you say, no, I don't, then I'll go back and show something else.
Yeah, you just broke it down, but without the step in the middle where
Exactly. But is everyone comfortable with this? So all we have to remember is we have here two factors at the top. These two will have plus in front. Yes, we work on them a little bit more, but they will have plus. We have one factor in the denominator, so there is only one minus. Same thing here. I have 1, 2, 3 factors. All these three will have plus. Log of 10, log of x squared, log of the cube root. But I have two factors in the denominator. So then, though their logs will have minus in front. So then minus log 7 minus log x plus 1 squared. Now we still have to clean them up. Does anyone remember how much is this? Assuming you don't, here's another way. Here's your log and plug in 10 and tell me what you get. Of course. Thank you, Kevin. I saw that. It is 1, so I have to replace it. I have to simplify it. This I cannot simplify because I don't want a irrational number in there. So if you plug in log 7 and you press enter, look what you get. So that cannot be simplified. And even if you try to change it into a fraction, it's not going to work. So, but this I have to. This one has to be cleaned up because I have a property that I can apply, which means the power goes in front as a factor. So I'm going to say plus 2 log x. Now I have to remember that this is basically 1 minus x to which power? Can anyone give us the power on 1 minus x?
To the third.
Careful.
1/3.
Excellent. I completely agree. So then I have to put it in front. So plus 1/3 log of 1 minus x. Great job. I have no choice but copy this. But then here I can put the 2 in front. So minus 2 log x plus 1. It's completely cleaned up. There are no more properties to apply. I want to draw your attention because it's very easy to forget. I'm going back to the properties. Please pay attention. Product, quotient, power. We never said anything about a property on a difference or a sum. So do not attempt. It's tempting. Do not attempt to do anything to this. There is no property for log applied to a sum. This is carved in stone. It stays like that forever. The same thing here. Carved in stone. We only have product, quotient, and power. We don't have log applied to a difference. Done. That's it. We don't have log applied to a sum. Do we still need expanding?
No, but I have a quick question.
Please do.
Okay, so since it's a log and then in parentheses it's x plus 1 and then the other one's just 1 minus x.
Correct.
Oh, never mind. I just saw it. I was answering my own question.
No worries. I love it when my students answer their own questions. I don't have to do anything. Good. Do we need more expanding? If you say yes, let's choose. If you say no, we'll move on to condensing now.
No, I think I'm good.
Okay, so in all these examples, the last two examples, we use the properties to expand into simple logs. As simple as possible, applying all properties. We only have 3. Same thing here. This was a huge, complicated expression. We came down to very simple logs. No more properties can be applied. Now, we will be given this, we will be asked to condense it into something like this. So this time when we condense, we go backwards from blah, blah, blah into 1 log with 1 in front, nothing else in front. 1 log, whatever base, we don't care, of a condensed expression. That's what we're doing now. So, yep.
I was looking through the next set of like condensing
Yes.
problems. And I just wanted to ask this question before we got into it.
Yes.
So, is it, because I don't see any in here, is it possible to condense something that has both log and ln in it?
Very good question. The answer is yes. In this class, no. But I'll show you an example, since you asked. So let's say I have log base 3 of x added to log base 4 of y. That's what you had in mind, correct?
I meant like if you have ln and log.
Good. And ln z. Is this okay?
Yes.
Okay. These are 3 different bases. I will change, since we want to keep natural log because natural log is in the calculator, I will keep natural log, but I will change these into their corresponding ratios. ln x over ln 3, ln y over ln 4, plus ln z. I use the change of base formula. With log base 3 of x, I change it into natural log x over natural log 3. I change this using the same change of base formula into log of y over log of 4. This is, I draw your attention, this is not log of x over 3. This is log of x over log of 3. So now, I have to change this into 1 over natural log 3 times natural log x plus 1 over natural log 4, because it's a constant, times natural log y plus natural log z. This becomes, going back, the power of z. It's a constant. Goes back, becomes the power of y. I know, it looks awful. And now I have this. So is it possible? Yes. In this class? No. We're not doing this in this class. There is no need. But yes, because I can change any log you want into natural log or common log that I want, that the one or the other. And this is a constant. It goes back to being the power. If it's in front of the log, it really came from the power of x. So I change this, and now I can change it into a product. But there is no need for this. You're not going to be asked to do this. But it's a very good question. Thank you. Good. So now let's choose